Okay, so in this video, we're going to continue on in our talk about thermodynamics. In the last video, we talked about the laws of thermodynamics. Um, and in this video, we're going to talk about different methods of heat transfer. And so we've talked about heat before. Heat is basically the transfer of thermal energy from one place to another place. And as we talked about in the last video, thermal energy can be transferred as heat between a hot object and a cold object. And generally speaking, one of the statements of the second law of thermodynamics is that heat naturally flows from a hot object to a colder object. Okay, now I talked about in that video you can make the opposite thing happen, but you have to do work for that to happen, and that's like how a refrigerator works, or like an AC system. But generally speaking, heat naturally flows from hot to cold until you get what's called thermal equilibrium. And thermal equilibrium basically is a situation where two objects reach the same temperature and there is no more net heat flow. Okay, and so for example, let's say you have a hot cup of coffee and you leave it on your counter for like 5 hours. Eventually, the coffee is going to cool down. Obviously, heat is going to go from the room into the coffee, or sorry, from the coffee into the room because the coffee is hotter than the room. And eventually, what's going to happen is the coffee is going to reach the same temperature as the room. It's going to reach thermal equilibrium as the room. And since room temperature is usually like 70 something degrees, we would describe that coffee as cold. Um, it wouldn't really technically be cold. It would just be the same temperature as the room. So that's an example of thermal equilibrium. Now, there's three methods of transferring heat from one space to another space that we're going to talk about, and you've probably learned about these before in your past science classes. And so these are conduction, convection, and radiation. Those are the three methods of heat transfer that we're going to be talking about, and we're going to start off by talking about conduction. And so I will briefly describe what conduction is, and then I will link, and I'll also give you some examples, and then I will link one or two videos for you to watch related to conduction. Okay, and so conduction is the primary method of heat transfer when you're talking about solids. And the reason is the way conduction works is in a solid you have atoms that are vibrating. Okay, we saw that like in the very first video, that in solid the atoms or molecules are close together and they're like shaking in place, they're vibrating in place, and temperature kind of like measures how fast they vibrate, right? So in a solid, the atoms are close together, and what can happen is that you can actually have atoms collide with the atoms next to each other, and when they collide, they can transfer some of their energy. And through those atomic collisions, heat can be transferred from hot to cold. And so, in one of the video clips I'm going to show you, let's say, for example, you have like a metal bar, and you stick the metal bar in the fire. Well, if you keep holding the middle bar, eventually your hand is going to get burned, even if your hand is not in the fire, because heat is going to transfer from the side of the bar in the fire up to your hand. And the way that happens is through conduction, because the atoms in the middle bar collide with each other, and the collisions is kind of like a domino effect. Those collisions keep going until they reach your hand. And so conduction you typically see with solids and you see with direct contact because you have to have the atoms have to be close together in order for the collisions to actually happen. Okay, so that's why you typically only have conduction with direct contact, and usually only with solids. You can have conduction with like liquids or gases, but it's not quite as common. And so I'm going to link a couple of videos just so you can see some examples of conduction, and you can get some more notes about conduction. But some examples I gave you on this slide: one end of a metal bar getting hot when you stick the other end in a fire. If you touch a hot doorknob and you get burned when there's a fire, that would be an example of conduction, because when you have that direct contact, the atoms in the hot doorknob are vibrating really fast. And when you touch the hot doorknob, those vibrations can carry over into the atoms making up your finger. And that's how heat can go from the doorknob to your hand. And so I will link these videos in so you can learn more about conduction. Okay, so that is conduction. Let's talk about convection. Convection is the method through which heat is transferred in a liquid or a gas. And when we talk about a liquid or a gas, we collectively refer to a liquid or gas as a fluid. And so a lot of people, when they think of fluid, they think of a liquid, but technically gases can also be fluids because a fluid is just anything that floats. And so when I say, a hot fluid, that could mean like a hot liquid or a hot gas, either way. Okay, and so convection is typically how heat is transferred through a fluid. And basically the way it works is that when you have a hot fluid tends to become less dense because it if it's hotter, it spreads out more and it occupies a bigger volume, and so it becomes less dense. And when that happens, the fluid tends to rise. And then when it cools, it becomes more dense and it falls, and this can create what's called a convection current. Okay, and so some examples of this would be like, if you have a room that's on fire, the hot air and the smoke is going to rise to the top because of what I just described. And that's why they say if there's a fire, you should get on the ground and crawl because all the dangerous smoke that's bad for you is going to rise to the top because that hot fluid, the hot smoke is going to become less dense and go up. If you've ever cooked like spaghetti on the stove, like if you've ever watched like a pot of water boil, you see that the water boils up from the bottom to the top and then it kind of like circulates. And so if you have like spaghetti in a pot of water, it can actually like stir the spaghetti. The water boiling can actually stir the pasta because it just keeps like circulating. The hot water goes up and then it cools down and then it goes back down and it creates these currents. If you've ever like felt the air above a fire, um, get hot without actually directly touching the fire, that would be an example of convection because, again, you have like a hot fluid rising up. And so there's lots of different examples of convection. I could also talk about convection as it pertains to like the weather, like things like wind and storms and bad weather and tornadoes, all that stuff. Is created from convection. Like we got a bad winter storm a while back, and one reason for that is because we had weather come down from the north and um, uh, get really cold here in Texas, and so these giant weather systems can form like all over the planet because some parts of the planet are hot and some are cold, and so that causes like the air to warm or cool in certain ways and then travel across the planet. And so there's lots of interesting examples of convection. I will link a video having to do with convection just so you can get some extra notes. Okay, so check that out. Okay, and so you can take a look at a couple examples having to do with convection. So here it says convection occurs when fluids like a liquid or gas move around due to temperature differences. And so let's say I have like a candle and I want to roast a marshmallow using my candle. Where should I put my marshmallow, do you think, to heat the marshmallow using convection? Okay, so hopefully you figured out that the marshmallow you should put here at position A right above the candle because what's going to happen is heat is going to flow up. The hot air is going to become less dense and rise, and it's going to go up, and it's going to go straight up above the candle. And so point A is going to be the hottest location, whereas like B, C, and D might still be kind of warm, but you don't get as much heat from convection because heat rises with convection. That's the idea. All right. If you've ever seen like a lava lamp, that also works with convection. Because basically, a lava lamp, there's like a light bulb in the base, and so when you turn it on, like this liquidy stuff, like as it gets warm, it like goes up to the top, and then as it cools, it goes back down and makes all these cool shapes. So lava lamps work using convection. And the third method of heat transfer is what's called radiation. Okay, and so radiation is a really important method of heat transfer because it's the only method of transferring heat that does not require a medium. It does not require a solid, liquid, or gas for the heat to travel through. And so conduction and convection require a medium, either a solid, liquid, or gas, but radiation does not because it transfers heat by electromagnetic radiation. And so the way it does that is that all objects in the universe that have temperature emit this electromagnetic radiation. When we talk about heat, the type of electromagnetic radiation that we care about is what's called infrared radiation. or infrared photons. So all objects emit um, infrared photons. A photon is just a particle of light. Okay, so imagine everything in the universe is giving off these particles of light. Some things, if they're hot enough, give off visible light. Like if you have like a piece of metal that's super, super hot and it's like glowing red, that's giving off like, red light. Okay, but most objects, whether it's like a light bulb or a human or the walls in your house, um, give off photons that might not be visible light, but they might be infrared light, okay, which infrared light is heat. Okay, so infrared photons, humans perceive that as heat. So if you've ever seen like thermal imaging cameras, those basically can detect those infrared photons. Um, and then those infrared photons that are emitted by all objects can be absorbed by other objects and then be perceived as heat. And so um, with heat transfer by radiation, you don't require any direct contact, you don't require a medium, and in fact, infrared radiation, all electromagnetic radiation actually can be transferred through space. Okay, and so this is really important because this is how we get heat from the sun, because there is no medium in space, there's no air in space, it's like an empty vacuum. And so the way that we get heat from the sun, as well as light, is through heat transfer by radiation. Those infrared photons come from the sun. We also get some ultraviolet photons, some visible light photons. Obviously, we get light from the sun, but those all come from the sun, travel through space, and arrive at Earth. And that's why we get heat and we get sunlight and stuff like that. Um, and so, just some examples of heat transfer by radiation. I already talked about the sun heating Earth through space. Any heat transfer going through space involves radiation. But if you also talk about like a light bulb giving off heat, typically that also emits heat through radiation. Now, it depends on kind of like where your hand is relative to the light bulb. If you, let's say you have a light bulb and it gets hot, if you hold your hand directly above the light bulb, that might be heat transfer through convection because then the hot air is going to rise up into your hand. But the light bulb itself is going to emit those infrared photons in all different directions. And so even if you're not directly above the light bulb, if you're just off to the side, you can feel the heat from that. Or if you have like a radiator or like a space heater, heating your room, those emit infrared radiation to heat the room. I also want to tell you that a lot of the time, if you have like a remote control, like for your TV or something like that, those typically work using infrared radiation. Usually they're weak enough that you can't feel any heat coming from them, that they don't have quite the correct energy for that. Um, but that is also technically an example of infrared radiation. In fact, if you ever want to try to see that, if you get your TV remote, um, a lot of phones have the ability where if you have your selfie camera on, if you point the remote at the selfie camera, you can actually see there's a little light bulb at the end of your TV remote. When you click a button, you can actually see that light bulb light up on your selfie camera on your smartphone, and you can't see it with your eyes, but a lot of selfie cameras, like I know my iPhone, can see that little flashing light, and so that's something you can check out for yourself. So I'm going to share a video having to do with radiation, heat transfer by radiation, so go ahead and check that one out. Okay, and then these last few are just kind of diagrams showing, how you can have different methods of heat transfer in the same situation. So for example, let's say if you have like a pot of water in a metal pan and you hold it above a campfire, um, the fire gives off those infrared photons, and so the fire gives off energy and heat through radiation. But there's also some convection because the air is going to get hot and rise and go up into the pot. And then if you're touching the pot, and let's say the pot has a metal handle, then your hand can actually get burned through conduction. Okay, and so you can have, the same situation with more than one type of heat transfer at a time. Okay, and then finally, we're just going to do a few more examples. Um, Here we have a situation where you're asked to label like how um, how you would experience transfer of heat in these different situations. Um, and so, for example, if you're touching, let's say you're holding a spoon over a flame, the fact that there's direct contact there indicates that that would be heat transfer through conduction. If your hand is over the fire, remember, in a fluid like with air, heat rises, right? And that is involved with convection. And then you would feel heat off to the side because of radiation, because the direction doesn't matter with radiation, because objects emit infrared photons in all directions, up, down, left, right, whatever. Okay. And so on this next slide, I wanted to try to label some of these situations on your own. Okay, so here we have 1, 2, 3, 4, 5 examples of different situations, and I want you to try to label them with the correct method of heat transfer. So try to do that on your own now. Okay, so let's see how we did. The metal knife gets hit sitting on top of the toaster. If it's directly touching the toaster, remember direct contact, you typically have heat transfer by conduction. Your steak gets grill lines on it from where it touched the grill. Same thing. When you have solids in direct contact, that's typically going to be heat transfer by conduction. The heat you feel when you stand next to but don't touch a hot oven. Okay, and so remember, when you're talking about convection, you're talking about heat rising. Okay, if you're not above a hot object but you're still feeling heat from it, then that's probably heat transfer through radiation. Okay, because hot objects can emit infrared photons in all directions. The hot water in a pot rises to the top, gets cold, sinks down, and then gets hot again. That is just describing a convection current, so that is convection, convection. And the smoke from a fire rises up a chimney. We talked about that earlier. That would be convection as well. And so hopefully you got all of those um, correct. As always, please let me know if you have any questions, and I'll see you guys in the next video.